Okay, this video is going to walk through Chapter 11, finishing up our annuities using our time value of money keys, and then getting into the bonds and the stock tables. So this one we have after a terrible cyclone in Bangladesh, an international disaster relief organization agreed to help support several families who lost everything with a payment of $25,000 every quarter for 5 years. Find the lump sum that must be deposited today to meet this need, and then the interest earned. Whoops. Go back. Sorry about that. Go back up there. Okay. So we're going to put it into our financial calculators. So our N is going to be 5 times 4. Now I'm in Excel, so it's going to want me to do it like a formula. So 5 times 4 is 20, and that's going to be my N. The IY is going to be 6%. Whoops. But then divide that by 4. So 1.5 is the IY. The present value is what we're computing. So we'll skip over that for now. The payment, $25,000, that's what they've agreed to pay every quarter for 5 years. And then there's no future value. They don't agree to pay anything at the end. They're just paying the $25,000 for 5 years quarterly. So then I'm going to flip over here, and hopefully this works. And then go to my, no, we don't want to, see that's the thing, it's just probably going to be ads in here. Let me see if I can make this go down a little bit. Go up a little bit. No, okay. Let me see if I can. There it goes. Okay. So then this is a free, let me scooch it over, see if we can, I guess I can put it right there as long as we can see the problems. Okay, so it's a free app on the computer for the financial calculator, similar to the emulator that I bring up. So 20, type that in, push N, 1.5 is the IY, 25,000 is our payment, zero out the future value, and then now tell the calculator to compute the present value. So 429,000, I'm going to put that 429,215.97, because I think it'll go away when I come over here. So that would be the lump sum that must be deposited today. And then the interest earned, you want to take that 429,215.97 and then compare that to the money that they're paying out. So 20 payments times the 25,000, they're paying out 500,000. So then our difference between those is going to be our interest. So $70,784 would be our interest. Okay, then we come down to the next one. In 4 years, Jennifer Vedetto will need to purchase a delivery van for her plumbing company. She estimates that it will require a down payment of $10,000 with payments of $950 per month for 36 months. Find the total amount needed in 4 years, assuming that 12% is compounded monthly. And then, will she have enough if she invests $2,200 at the end of every quarter for 4 years if she earns 6% compounded quarterly? Okay, so she will require a down payment of $10,000 with payments of $950 per month for 36 months. So find the total amount needed in 4 years. So now this one is a future value. Find the total amount needed in 4 years. Now this one, because it's going to be $10,000 down, that should be our present value. So this one's a little bit different. We don't normally have all of those values, but we'll put in our present value is 10,000. Our $950 is going to be a payment, and then we're going to be computing that future value. 36 months is our N, and then 12% compounded monthly, 12 divided by 12 would be 1% per year. So, so we'll go over now. I'm struggling. I feel like these have to go the same direction though. So I think I'm going to have to make my payment also negative, because this is, think of cash flow. This is money I'm giving up, and that's money I'm giving up. So what would be the future value of that? Okay. I still feel like it's worded a little bit weird, but I think I have it set up how it wants us to do it. All right, so now let's go back and bring that calculator up. Okay. So 36 is our N. 1 is the IY. Again, these are going to be the same direction because it's money I'm paying. So I'm going to make them both negative. So 10,000, push the plus or minus button, push the PV button, paying out $950. So make that negative, and that's the PMT. And then now compute the future value. So 55,230.72. So that's how much they would need, or that's how much they'll end up they'll end up paying if they go this route. So then now the second half, then will she have enough if she invests $2,200 at the end of every quarter for 4 years and earns 6% compounded quarterly. So then 4 years with 4 quarters, 16 is our N. 6% divided by 4, whoops, we want that to be a number. All right, let's go up here and make that a number, but not a dollar. We'll make it that way. All right, so 1.5 is our IY. There's no present value in this one. She's not doing anything today. But she is saving $2,200, and I'll make that negative as our payment. And then we are computing the future value. I'll just put that over here since I didn't leave a space. Okay, so we'll come back to our calculator. 16 is our N, 1.5 is the IY, no present value, 2,200, again, we'll make it negative by hitting the plus or minus button, is our payment, and then we'll compute the future value. So no, 39,451.21. She will not have enough money if she does that. Okay. So then we'll go down to this next one, and that is that ends section 2. Adolph Hegman has 2 offers for his Canadian grocery company. The first offer is a cash payment of $540,000. So that is already today's value. So we don't have to do anything to that number. The second offer is a down payment of $240,000 with payments of $65,000 at the end of each semi-annual period for 4 years. Identify which is the better offer, assuming 10% compounded semi-annually. So again, we don't have to do anything to that one. The second one we do, but not to the down payment. That is also already in today's values. It's the future payments. So there's payments of $65,000 at the end of each semi-annual period for 4 years. So our N is going to be 4 years times 2. So 8's our N. 8% again divided by 2 because it compounds semi-annually, and I don't know why it wants to be a date. but it's 5. The present value is what we are computing, and the payment is the $65,000 and no future value. And then again, we won't worry about making it negative because we're computing the present value, so that will end up being negative. So 8 is our N, 5 is the IY, 65,000 is our PMT, no future value, so zero that out and then compute the present value. So 420,000, 108.83. Now that's not, we don't compare those yet though, so that says, okay, that's the present value of those payments. We still have to factor in the down payment. So the 240,000 is a down payment. So then in total, we add those together, and that is the comparison. So it would be better off to take the second offer where we're going to get $240,000 down and then $65,000 twice a year for 4 years. We would end up with more money. And then find the difference. Again, just subtract them. So that minus that gives us that difference. So just read these ones carefully. I felt like most of these ones wanted us to compute the present value, except for number 14. That just the way it was worded, it doesn't sound like a present value one to me. But so read those ones carefully to make sure you know you're computing the right thing. If they give you money today, like a down payment, that is already in the present value, so you shouldn't have to do anything with that. You would just compare it to the other ones. Okay, then section 3 is our sinking funds. So our sinking funds, we normally have a goal, and then we have a time frame, and we're looking for what our payment is, and there's no present value in these sinking fund ones. So scuba diving, the owner of Emerald Diving plans to buy all new scuba diving equipment to rent to divers in 5 years at a cost of $122,300. He believes that he can earn 4% compounded quarterly. Find the amount of each quarterly payments needed and the interest earned. So he's got 5 years and it's compounded quarterly, so that's 20 quarterly payments. He's earning 4% compounded quarterly, so that's that. I don't know why. I'm going to just highlight this whole thing and say, okay, go back. I don't know why it wants to default to a date. So 4 divided by 4, it's going to be 1. Our present value is nothing. They don't say anything like they're putting any money down today. We want to know how much do they need to save quarterly, so we're computing that payment. And $122,300 is our future value. So again, we'll flip back over to the calculator, put in 20 as our N, 1 as our IY, no present value, so skip over that. 122,300 is our future value, and then now compute the payment. So $17,726.17 is the amount that they would have to set aside quarterly to get there. And then our interest earned, again, it's the payment times the N. That's how much money they are putting in. That can't be right. Let me go back to my calculator. Yeah, so I mean, all those look good. Why does that seem like it's such a huge, oh, maybe. That's better. Okay, sorry. So see, I had a value in my present value. I didn't zero it out. So $5,554.29. Now that seems high as well. I feel like I'm doing something wrong with this one. Let me make sure my formula is still. Oh no, that's right. Sorry, this formula's fine. It's just the difference. Because it's way too high for interest. But no, that looks good. That looks much better. How much they put in compared to how much they ended with, and that is our interest. So I forgot to zero out my present value, which messed up my payment. So that was my mistake there. But then once you have your payment, then multiply that by your N. So that's what this formula is. Your payment times N, that's how much money they put in. And then the difference between that is our interest. Okay. Then we've got Cajun Jack needs $45,000 in 4 years for boats used to hunt alligators. Find the amount of each payment if the payments are made at the end of the quarter with interest of 6% compounded quarterly, and then find the amount of the total interest. So again, the same thing as what we just did. Oops, sorry. So our N is 4 years in quarterly payments. So 4 times 4, we've got 16 quarterly payments. We're earning 6% quarterly, so 6 divided by 4 is 1.5. I'm not sure why it makes me, I'm going to let that go though, because it is 1.5. The present value, again, nothing down today. We are computing the payments. We want to know how much he needs to set aside every quarter to have the $45,000 as our future value. So again, we'll come back to our calculator. 16 is our N. 1.5 is the IY. No present value, so we'll zero that out. 45,000 is our future value, and then we'll compute the payment. So $2,509.43. And then our interest, again, is going to be, whoops, I could put an extra period in there. Our interest is going to be the N16 times our payment amount. So that's how much money we put in, and then the interest is going to be the difference. So $4,849.12. And then our last sinking fund one, again, same keys on our calculator. So I'll list those out. The membership of the Green Acres Baptist Church is large and growing rapidly. The leaders of the church are planning to remodel the auditorium with special features for their televised broadcasts at a cost of $2,800,000 in 5 years. Membership has set up a sinking fund with the idea of making a payment at the end of each quarter. Find the payment needed if money earns 8% compounded quarterly. So we've got 5 years and it compounds quarterly. So that's 20 quarterly payments. 8% a year divided by 4. So that's 2% per quarter. Not starting with anything today. And we are computing for the payment that needs to be made at the end of the quarter if they want to have $2,800,000. So again, coming back to our calculator, 20 is our N, 2 is the IY, no present value, so we'll zero that out. 2,800,000 is our future value, and then we want to compute the payment. So 115,238.81. So that would be the payment needed at the end of every quarter. Is that seems like also not enough. Let me go back there. Let's see. I guess that is, yeah. Okay, so that's fine. Okay, so then that is our sinking fund. Then we go into section 4. Now, so section 4, as I look through these, I don't think there's any that use our time value and money keys. We're going back and we're looking at this table, which is provided in the textbook. So it gives you the company, their opening share price, their range, which would be their low and their high over the past year, their volumes, and then their market cap. So, so for these ones, so I think I've asked for number 12. We can do, and we'll do 12 and 13. So 12 says the dividend yield for Home Depot. So if we look through this list, I am cutting off the very end of it. So hopefully, I didn't cut off Home Depot. No, okay. So Home Depot's down here. So then our dividend yield for Home Depot, if we keep going across, we have the price to earnings ratio, our earnings per share, then we have our dividend per share. So our dividend per share is $8.30, but I don't think that is what it's asking for. So our dividend is $8.36, but our yield is going to be the 2.86%. So I think that's what it's actually asking for. Yeah, the dividend yield is 2.86. And you should be able to compute that. Sometimes though with these dividends, the dividends in the table are quarterly, even though it doesn't tell us that. Let me just double check if our price is $292.15. No, that's not it. So 8.36 divided by 292. Where was I at? 292.15. Yeah, that's how it's calculated. Okay. So in this case, the dividend is fine. Be careful sometimes with the homework though. They give you, it's a quarterly dividend instead of an annual dividend, but this one works out to be the correct number. So it is the annual. Okay. Then 13 says, what is the high price for Tesla? And again, I might have cut Tesla off though. So if I did, let's go up, let's do number 11. So I hope I didn't cut Sony off. Oh, look, I have more. Sorry, yeah. But I think I still cut Tesla off. So Sony, the opening price for Sony was all the way over here. So the $90.85 would be the opening price. So you got to just kind of watch what it's asking for, watch the headings of the columns, and just make sure you're in the right category. Okay, then we have enterprise products, which is right here in the middle. Find the cost for the following stock purchases at the opening price, and then find the annual dividend. So for number 20, for enterprise, the opening price, again, is that far number to the left. So it's $26.95. And then our annual dividend is going to be, again, let me go up so we can see the columns a little bit better. So the annual dividend is going to be that number there. So if we carry that all the way down to enterprise, it would be $1.96. And then if it asked for the yield, which it doesn't, but if it did, you would just divide those. So the dividend divided by the price gives you the yield. And then again, that would be a percentage. So that just kind of tests your knowledge, reading those tables and answering the questions. Then again, so we'll do one more down here. We'll do McDonald's or Meta, whichever one we can see in the table. Do I not see either one of those? What about United Parcel Service? I feel like I didn't cut that much off, but I must have cut enough off that, all right, well, I guess we'll skip those ones because I feel like I've cut them all off. Okay. But you would just do that same thing, what I did up there. So I did the opening price, the annual dividend, and then calculated the yield. Okay, then our last section deals with bonds, and we go to this bond table, which I think I've got the whole one in the picture here, though. So number 16 and 17, the city of New York purchased 10,000 bonds issued by Ford Motor Company. So as we look to the right, we see the Ford, or to the left, sorry, the Ford Motor Company kind of right there in the middle. They're maturing in 2046. Do I see? Oh, yeah, that's the date. So see the date there. That's our maturity date. The commission is 20 cents per bond due to the large volume. Find the total cost, including commissions, the annual interest, and then the effective interest rate. So for our first one, we have 10,000 bonds. And then we are paying, if we come over here, again, Ford, go across, our last price. So we see 98.996. But what you want to remember is that is a percent. So then really I have to say, and let me go out let me see all the decimals. So just make sure you're entering it as a percent and including all your decimals. So then we're going to say, okay, we're buying 10,000. Oh, and then, sorry, then what you also want to remember is their $1,000 bonds. So that's our par value. This is our quantity. And then that is our price. But again, it's a percentage. But then now we can multiply those. So our quantity times our price times the percentage. That's how much we're going to pay, and then plus commission. And then our commission was 20 cents a bond. So we're going to pay another $2,000. So then we will sum those up. So that's our total cost. Then B says, find the annual interest. So then, again, we have 10,000 bonds at $1,000 a bond. Now, in this case, the interest is going to be the coupon. So go down to Ford. The coupon is 5.291. Oops. But again, it's going to be a percent, so I probably have to change that up. So 0.0529, and if I want to turn it into a percent and show you all the decimals, though, there. So then remember, even though in nowhere does it tell you those are percents, they're always percents in these bond tables. So then we take our quantity times our price times the quoted coupon rate that they pay in interest, and that's how much interest is paid. And then our effective rate is going to be the interest that we earned divided by the total cost that we have. And again, this would also be a percentage, and we can go out however many decimals we need to. So 5.34%. And then we'll do the same thing then for number 17. So now Roberto Martinez needed more income than offered by the money market funds, so he purchased 20 Wells Fargo bonds that are due in 2046. So we look over here, Wells Fargo, due 2046, so those are the bonds. And he purchased 25 of them. So our quantity is 25 bonds. Our price, again, is going to be the percentage. And it is Wells Fargo 99.004. Okay, and maybe I go out one more so we see all of it. Okay, and then again, the par value is always $1,000, and then now we're going to just multiply those. So the price times the quantity, times that percentage is how much he's paying today. he's paying a commission of $25, or sorry, $1 a bond. So that would be $25. So again, just the price times the number of bonds, 25 bucks. And then we'll sum those up. So that's going to be his total price. I can delete that row so we don't. Okay. Then how much interest is being paid? So again, 25 bonds at $1,000 a bond, and then go back to the coupon rate. So Wells Fargo is 4.75%. So that is our rate. And then we're going to take our quantity times our price times that coupon rate. And that's how much interest they will get paid. And then C is what are we earning. So then you take the interest that they'll get paid divided by the cost that they have invested. And again, we'll make that a percent and go out. So they're earning 4.793%. And as you compare that to what it shows over here, you see it's just a little bit different because of the price difference. Like neither one of these did we pay the full 100%. We got both of them at a little bit of a discount. So that means we earn a little bit more. Okay, so then that completes our Chapter 11 in-class exercises.